Hello, good morning, everyone. Okay, good morning, Yiru. Good morning, Ho. Can listen me or not? Okay, we want to check is it the mic can function or not. Can listen me? Hello. Good morning, huh? Okay, can listen me or not? Please respond here. Can or not? Can, huh? Okay, so today I want to complete about this topic. There's the last one, 6.2. There's a nuclear energy. So the module I already upload in the Google Classroom. That means the student you can go to download. They got some of the tutorial question. You also need to answer it. Okay, after this one lesson, that means you need to do about the module. Okay, let's see this one topics. We still continue with the 6.1, related sum of the alpha, beta, and also the gamma. Okay, so from here, today the lesson is a 6.2. Okay, there is a nuclear energy. So that means we still learn about the energy. Remember, energy we must using the unit. There's a joule. Okay, so from here, nuclear energy also the same lah. We're still using the unit is a joule. Okay, now we need to know is how to produce the nuclear energy. Okay, so let's see the, okay, nuclear energy actually what's the meaning? Okay, that's a atomic energy can release during the nuclear reaction. So nuclear reaction example is what we learn, alpha decay, beta decay, and gamma decay. This all we call it as a nuclear reactions. Every reaction they also produce a energy, so we call it as a nuclear energy. Okay, nuclear energy. So example, they say the radioactive decay, okay, nuclear fissions and nuclear fusions. Okay, the first one, radioactive decay, we learn already. There's a alpha, beta, and gamma decay. But today we need to learn is a nuclear fissions and nuclear fusions. These two things also can produce a energy, and also the energy is a large amount. Okay, more and more compared to the normal radiation decay. Okay, let's see what is these two process. Okay, nuclear reactions, they're separate by two. Okay, first one, nuclear fissions. Okay, remember the name, almost the spelling is the same, but you go and see, be careful. This one is a double S, fissions. This one we call it as a nuclear fusion, Fusion. Okay, what is the similarity for these two process? Produce nuclear energy. Okay, when they just do the process, sure they will produce a nuclear energy. And the next one is loss of the mass. After the process, they sure will lose the mass. Okay, for this one, nuclear fission and also the nuclear fusion. Okay, when they lost about the mass, we call it as a mass defect. Okay, we never say about loss of the mass lah, but the meaning is a loss of the mass. When you see the word, there's a mass defect. Okay, then we go through one by one. Okay, first one is the nuclear fissions. Okay, double S. Okay, you see what's the meaning for nuclear fissions? All the keyword I already highlight by using the green color. So you can see very careful. Nuclear fissions is a nuclear reaction when a heavy nucleus. So that means they must start from the heavy nucleus. Example, uranium. Uranium is a one of the big nucleus. After that, they will split. Okay, the bigger nucleus, they will split into the two or more lighter nuclei. So that means they will split, become two or more of the singular nuclei, while they will releasing a large amount of energy. So that means during this one process, the bigger size, they will split, become two or more smaller size. Then after that, they also will release large amount of energy. So this one we call nuclear fissions. Okay, let's see the example video here. Okay, just now it's a big size uranium. Okay, so uranium now they start with the nuclear fissions. So they will split. Okay, they split become the lighter one. Okay, after that they will continue and do the process. When they continue to do the process, we call chain reactions. Okay, first one is a nuclear fissions. When they continue to do the nuclear fission, we call it as a chain reaction. When chain reaction happen, that means you will produce more and more energy. So this one is one of the process how we get more energy from nuclear fissions. Okay, so we need to repeat and do the process. Repeat to do the process, we call it as a chain reactions. So important, you need to think about that. Nuclear fission, what's the definition? So you must say when starting must be the heavy nucleus. Then the heavy nucleus will split to the two or more of the lighter nuclei. After that, they also produce large amount of the energy. So this one we call nuclear fissions. Okay, let's see the example for nuclear fission. Okay, this one you can see the diagram. We start with the uranium. Okay, we got on one of the neutron. So this one neutron, they must hit the uranium. If not, the uranium cannot suddenly go to split. So the neutron must be very fast. After that, they hit the uranium. Okay, when they just hit the uranium, they combine together. Okay, when they combine together, you can see the nuclear number 235, they will plus 1 because neutron is a 1 nuclear number. So this one become 236. Then the proton number is no changes. So when they just hit to the uranium, then they become one is the unstable nuclear. Now the unstable nuclear, they need to split. Okay, split with two lighter nuclei. One is a barium, another one is a krypton. Okay, this one what they split, we no need to memorize. Okay, what they produce we also do know. Important, we just know they will split. Okay, two or more of the lighter nuclei. Okay, what they split out, the nucleus must be become lighter. Then after that, remember they also produce three of the neutron. Okay, don't forget the last one sure is a large amount of energy lah. So this one should be the process for nuclear fissions. Okay, we see by part lah. Okay, this one is a before they produce splitting. So we call it as a uranium 235. Nucleus is bombarded. Bombarded means they join together. After that, they bomb explode. So by the neutron. So that means there is must be bombarded by the neutron first. Okay, after that they produce an unstable uranium. They become 236. Nucleus is produced after bombarded. Okay, now they start to split. Okay, so from here a barium and also the krypton nucleus and three neutron are produced. So the energy also released. So this one is a process of the nuclear fissions. So that means we also need to write the equation for the nuclear fissions. So let's see the equation. Okay, we start with the uranium 23592 plus one of the neutron. So this one we call it the before collisions. We cannot say collisions before the split. Okay, before the splitting. So that means they must be bombarded by a neutron. Okay, after that they start to split. Okay, they split two of the lighter nuclei. The first one is a barium. There's a 141 and 56. Another one is a krypton 92 and 36. Okay, after that they got three neutron. Okay, and also plus energy. So these all equation when you plus together for the neutron number, suppose is the same. 141 plus 92 plus 3. Okay, they will become 236. Okay, proton number also same, 56 plus 36. Okay, they will become 92. Okay, so this one we call it equation for the nuclear fission. Okay, there's a big size. Then after that, bombarded with the nucleus, with the neutron. After that, split become two lighter nuclei. Okay, then you can see got extra three neutron, is it? Okay, so we go through to the next part. Okay, nuclear fusions. Just now is a fissions. Now it's a fusions. Okay, we see what's the meaning for fusions. Nuclear fusion is a nuclear reaction. Also, is a one of the nuclear reaction to form the heavy nucleus. This one is terbalik. Just now is what you split become lighter, is it? But the fusion they want to combine. Okay, they don't want to split. They want to combine. After that, they produce heavy nucleus. Okay, while releasing a large amount of energy. That means when they just combine, they also produce energy. So this one we call nuclear fusions. Okay, this one nuclear reaction they happen is under extremely high temperature. You want this one happen, they must under the high temperature. Example, the temperature from the sunlight. Okay, from the sunlight is very hot, so that means they need to happen must be under the solar system. Okay, and also must be the high pressure, then nuclear fission can happen. Okay, we can see a short video about how to form the nuclear fissions, nuclear fusion. Okay, we combine. Okay, let's see here. We got two lighter deuterium and also tritium. After that, they will combine together. Okay, when they just combine, that means they form a heavier nucleus. Okay, after that, they produce one of the helium and also the neutron. Okay, after that, they produce large amount of energy. So what I want you to differentiate is a fissions and fusions. Fission is a bigger size, split smaller size. Okay, fusion is two smaller size combined become bigger size. Okay, finally both also produce large amount of energy. Okay, so this one is a differences and also what should be the similarity. So you can see the nuclear fission, nuclear fusion. Nuclear fusion between the deuterium. So we're using the lighter one. Deuterium is a lighter one. Okay, after that we got tritium. Tritium also is a lighter. Okay, after that they combine. Combine to form one of the heavier helium nucleus. Now this part become helium. Combine together become helium. After that, they will come out one of the neutron and also large amount of the energy. Okay, so this one is what's differences between the fission and fusion. So we also got formula. Let's see the formula. Okay, first one is a deuterium. That's a 2. So we got 2 neutron number, 1 proton number. Then tritium. Tritium is a 3 neutron number, then 1 proton number. Okay, after that, when it just combine, they produce helium. Now the helium is a 4-2 plus 1 neutron. Okay, they produce one of the neutron, and the last one sure is a large amount of energy. Okay, so this one is an equation for the nuclear fusions. Okay, so until here, you understand about fission and fusion or not? Okay, so the student, you can give me the response, you understand or not, because we need to continue to the next part about the calculations. Okay, so you can just answer here, you understand about the fission and also fusions or not. So I need your response, then I continue the lesson. Okay, so who are on the chatting room now? Watching is got 22. Okay, we see the Yiru is here. Yiru, you still okay about the fission and fusions? Jessica? Okay, still okay or not? Okay, about the fission and fusions. Okay, so I continue with the calculation about the mass. Okay, the mass of the, okay, Katija say okay, Okay, we continue with the atomic mass unit. Okay, because the radiation, the alpha, beta, gamma, that one is very lighter. So that means we cannot using kg to calculate. We got special mass unit. So the mass unit, we call it as an atomic mass unit, or you can say AMU. So let's see the first one. The atomic mass unit, there's a AMU, there's a special unit they use to measure the mass for the atom, or you say subatom particle. Okay, subatom particle, we got what? We got proton, we got neutron, and also the electron. Because they're too small already, so we're using the special unit to calculate, to label, okay, the unit for the atom. So from here, one atomic mass unit, or you say 1U, well, 1 AMU or 1U, there's a 1 over 12 of the mass of the carbon. Okay, so we're using the carbon as a standard. So you want to calculate the mass of the unit, 1 unit of the atom, there's a 12 smaller. Okay, 12 times 1 over 12 smaller than the carbon 12 atom. Okay, now we go to check. If I want to convert become kilogram, so what we need to do? So we go to find out the carbon is how many first. The mass of the one carbon 12 atom, there's a 1.993 times 10 power of negative 26. The carbon already very small about the mass. Now your atomic is a 12 smaller, 12 times smaller, you know. So we need to calculate what is the actual answer. What is the mass of the atomic? So I take 1U equal to the 1 over 12 multiply carbon mass. Okay, finally I get it. 1U actually is a 1.66 times 10 power of negative 27 kilograms. Okay, this one normally the question you provided, we know how to memorize. Okay, so this one just introduce for you. AMU, I want to convert become kilogram. What I need to do? I need to multiply. Okay, 1.66 times 10 power of negative 27. Okay, this one number, how to get it? That's a from carbon. Okay, there's a 1 over 12 smaller than the carbon. Okay, so this one we call it as an atomic mass unit. Okay, let's see this part. In a nuclear reaction, or you say radioactive decay, total mass of the decay products, so that means the products the mass are always smaller than the total mass before the reactions. So that means we can say before reaction the mass must higher, after reaction the mass sure less. Okay, so they say this one the mass loss, we call it as a mass defect. Okay, we can another word we say there's a mass loss lah. After the decay, some of the mass already lost. Actually, where they lost? They lost as a energy. Okay, they lost as a nuclear energy. Okay, so from here you can see this part. This part is an example, okay, for the nuclear fissions. How I know there's a fission? Because the uranium is a bigger size. Excuse me. After that, you can see the split. Okay, when you see the split, sure it's a nuclear fission. Okay, so from here, the label for you. Okay, the first part, neutron. The neutron, they give you the AMU mass. That's a 1.00867. Okay, some student will ask me, can I using round number? I do want using x67. I straightforward take 1. Can or cannot? The answer is cannot. We must take the full number. Okay, full number, don't round the number. So this one is a neutron. Okay, after that, they will bombarded with the uranium. Uranium is how many? 235.04392 AMU. You must take full number. Okay, don't round the number. Okay, this one we call it as a before. Okay, before they go to split. Okay, after go to split, okay, they split by 2. There's a krypton. Okay, krypton, they give you the AMU already, 91.92611. Okay, after that, we got barium. Barium, they also provided the AMU. And also, don't forget, we got 3 neutron. So you need to take the 3 multiply AMU of the neutrons. Okay, so after that, you need to find finally they lost how many mass. Okay, means we need to find the mass defect lah from this one situations. Okay, now we go to find first. Okay, first one is total mass before the nucleations. Okay, before. So we take the neutron, the mass, plus uranium. So I get it 236.05259. Don't cut behind the decimal point or the number you need to write. Then you just write the unit is a AMU. Okay, let's see after the nuclear fissions. Okay, total mass after the fissions. So we just take the krypton plus the barium and also 3 of the neutron. So I get it. This one should be the number 235.86653 AMU. Okay, now I need to minus lah because I want to find the mass defect. Okay, so when I just go to minus, I take full number, go to minus. So I get it, the final answer is 0.18606 AMU. Okay, normally the question, they do want the answer in AMU. You need to convert to kilograms. So normally how we do it, we use the AMU to do the calculation first. Finally, you get the mass defect, baru you go to chain become kg. Don't go to chain first. If you go to chain first, there's so many procedure you need to do. Okay, we take the AMU, we do first. We do the calculation first. Finally, you get the final answer is AMU. Then you go to convert, become kilograms. Okay, so this one is a process how we go to find the mass defect. Okay, now we go and see the nuclear energy. Just now it's a mass, now it's an energy. Okay, both nuclear fission and also the fusion, they also release large amount of energy. Okay, this one, the source of this one energy form from where? From the loss of the mass. Because of loss of the mass, so they will produce the energy come up. So the sum of the mass particle, okay, the sum of the masses particle before the reaction is more than the sum of the masses of the particle after reactions. So that means when we just plus together before the reaction and you plus together with the after reactions, you find it, they will become equal. Both will become equal. So let's see. Mass defect. Another meaning, mass loss. So from here, masses before reactions, you minus the masses after reaction, they call it as a mass defect. Okay, they call it as a mass defect. So that means actually mass defect from where? From energy. So that means the masses after reaction, you plus another energy, is it? Actually, overall is a masses before the reactions. So the relationship between the also energy, now we need to create the formula. E equal mc squared. Okay, this one's one of the formula I think everybody also listened before from the Einstein. That's a nuclear energy, E equal mc squared. Okay, we go and see one by one. What's the E? E is a total energy release. Okay, total energy release. Okay, M is stand for the mass defect lah. So that means you need to do the mass defect before you want to apply this formula. Okay, because you need to do the calculation first. Okay, after you find the answer, mass in kilograms. The mass must is kilogram because energy, the unit is a SI, that's a joule. And the last one is a C. C is the speed of the light. Okay, in the vacuum, I think everybody know, there's a 3 times 10 power of 8. That one sure constant variable. Sorry, not constant variable, there's constant value. So everybody, so in your mind, you must thinking the speed of light sure is a fixed one. Then you also must know lah, 3 times 10 power of 8. That one is a speed of the light in the vacuum. Okay, so from here, I introduced the formula already. Sure, they got question. Okay, so let's see the first example 1 question. Okay, the equation below they show about the radium 22688 decaying become the radium 222. Okay, and also one particle come out, there's an alpha. So understood this one is an alpha decay lah. Agreed. Now the question, you see what they want. Given the mass, okay, they give you the mass. Okay, for the radon, please you need to take all. Okay, this one's a radium. You need to take all number. Don't cut it. Okay, another one, it should be the Rn. Okay, there is a 222.018 AMU. And the last one should be the helium. Okay, 4.003 AMU. And the last one, you need to calculate the nuclear energy release. Okay, you want to calculate the nuclear energy release. So everybody, you know formula E equal mc square, is it? Okay, so the first step, we need to calculate what's the M. Okay, we need to count about the M. So now it's your turn to take your calculator to show me what is the M first. Okay, I want the mass. Okay, I want the mass in AMU first. You don't change. You take AMU first. Okay, so now I just left you to do the calculation for the this one, the mass defect. Okay, we try one question first. I want to see the question the student understand or not. Okay, anybody can tell me the AMU is how many for the mass defect? Okay, anybody? Mass defect. Okay, anybody can respond? The mass defect is how many? We just minus. Okay, you take before minus the after. Okay, before is RA. Okay, after is a RN plus HE. So that means you take the before, the number, you minus the after RN plus HE is how many? Okay, anybody can show me here? Okay, Ling Han give me 0.519 AMU. Okay, we go to check. Okay, yeah, correct. 0.519 AMU. Okay, now you help me to convert. Convert become kilograms. Convert become kilograms. Okay, you convert become kilogram, that means you need to multiply 1.66 times 10 power of negative 27. Okay, convert to the kilograms. Okay, the answer you get it just now, 0.519. Don't go to press 0. Straightforward, you go to multiply. Okay, multiply, make it become kilograms. Okay, we go to weight the student. Okay, Ling Han and Jessica, you can straightforward go to multiply. Then you get the answer in kilograms. Okay, we go to see, check it, got student answer or not. Okay, yeah, you give me already. Okay, 8.6154. Okay, we get full. Okay, yeah. I think the power, is it correct? Correct, is from the Jessica. Okay, Yiru, I think the power a little bit wrong. Maybe you're wrong typing or what lah. Okay, there must be power of negative 28. Okay, power of negative 28. So all the number you need to write full. Don't go to cut. So now I know the mass defect. So that means I can do the calculation for the nuclear energy. E equal mc squared. Okay, so now you give me the answer. Just now you press the mass defect already, is it? You straightforward. Okay, straightforward, go to multiply. Then you put bracket. Don't straightforward, then you multiply. I put bracket first. Bracket 3 times 10 power of 8. Bracket back. After that, you go to square. Okay, remember square. Okay, final answer. I want your final answer. Okay, the answer must be in joule. Okay, answer in joule. Okay, straight up multiply, put bracket. You must put the bracket first. Bracket, you open the bracket, 3 times 10 power of 8. Then you close your bracket. Then you go to square. Okay, any answer? About the nuclear energy. They're just simple of the calculation, but the problem is the number is too long. So you don't miss out one of the number. Okay, if you miss out one of the number, that means you get the answer sure wrong already. Okay, so anybody? Okay, get already. Yiru, 7.75. Okay, we're going to see. Okay, yeah. Okay, one thing to tell you, finally the joule. Okay, finally the joule you can cut. Okay, mass defect cannot cut, but the last one, joule, that means the energy, you can cut it, become 2 decimal point. Okay, you can write full, you also can be cut, because this one is the final answer. Okay, but the mass cannot cut, only the last one, the unit for the energy. Final answer, nuclear energy, that means you can short, make it become 2 decimal point for the final answer. Okay, so this one we call it nuclear energy. So normally the question, the format like this lah. Okay, the question don't call you to find mass defect, but the straightforward say nuclear energy. So that means you need to do another step to find the mass first. Okay, we got example 2. Okay, the sun they store about the energy to the earth. Now this one energy is produced by the nuclear fusion. Fusions. So you can see the equation they show is the fusion because they're using the small element. Okay, there's a deuterium and also the tritium. Okay, after that they produce a helium. So from here the question sure will give you the mass. If not, we don't know. Okay, so the question call you to calculate energy. Also is an energy. So this one should be the info. Okay, the info. Okay, first one, the deuterium is a 2.014. Number 2, there's a tritium. After that, they give you the helium. This one helium, He. I think this one got a little bit problem. Helium, this one is a helium, not 4.2, not 4.1. Okay, I go to change, because a little bit typing wrong. Okay, I go to change this one. There's a 4.2. This one is a 4.2. Then this one should be the helium lah. Okay, so I go to show back. Okay, here. So this one, there's a helium 4.003 AMU. Then you got one of the neutron. Okay, so now first one, I also want the same procedure. So give me the AMU first. Give me the AMU for the mass defect. Then the next one, you give me the answer. Chain become kilograms for the mass defect. And the last one, you give me the energy. Okay, so the first step, you give me AMU first lah. The mass of the mass defect of this one process nuclear fusions. Okay, then the mass, you give me AMU, then later you go to chain become kilograms, and the last one you convert become E equal mc squared. Okay, so anybody? Okay, give me the answer in AMU first. So Lincoln, can start already. So we wait the student to give me the answer for example 2. Okay, anybody here? They already get it, so you just type. Okay, you get already 0.018 must full, don't cut. So you go to show, 0.018 AMU. Okay, so the next step you need to convert. Yeah, correct, Linghan. Okay, now you straightforward type multiply with the 1.66 times 10 power negative 27, convert become kilograms. Okay, straightforward, go to convert. Okay, you convert become kilograms. Okay, after you convert become kilograms, then you baru can go to the E equal mc square. Okay, yeah, Jessica give me already. Power of negative 29, and then we go to check. Okay, yeah, 2.988 times 10 power of negative 29 kilograms. Okay, so this one should be the answer. So the next step, you go to convert become energy. Okay, nuclear energy. Okay, we're going to find the nuclear energy from the student. The unit is a joule. Okay, straightforward. Remember bracket. When you multiply the speed of the light, remember go to open the bracket. Okay, yeah, Jia Yao give me answer. Okay, you write short form also can. You can write full also can because this is the final answer. Okay, now we go to check. Okay, E equal mc square. So I go to type. Okay, you can make it become shorter. 2.69 times 10 power of negative 12. Or you can write in full also can. But important must have the joule lah. Okay, the unit you must mention here. Okay, so this one second question. Fusion already finished. Fission also finished. Calculation almost the same. So from here, we go through to the example 3. Okay, example 3 a little bit more easier because the question already give you the mass defect. Okay, already provided. So that means you no need go to do the the method. So from here, we straightforward. They want to find amount of energy release. Okay, you straightforward give me E equal mc square. What's the E? Okay, so from here, example 3, I wait the student give me the answer. Many of here also never entered the class. Yesterday, we got 4% never entered the class. Okay, so for me, I remember it's a Hari, Nixon. After that is KS. Then one more, who is that? Forget it, one more. Okay, never enter the class. Okay, maybe I go to check about the Google form lah. They never do it. Okay, so for this one, example 3, how many can answer? Okay, straightforward, take the mass defect, go to multiply the speed. Okay, speed of the light. Okay, speed of the light. Okay. How many can answer? You can type there. Okay, Rayan. Okay, Rayan, Yiru, you can answer. You can type here. Okay, we straightforward can get the answer. Okay, yeah, Rayan give me a D 1.548. Okay, so we go to pin. We go to chat. Okay, we're using the E equal mc square. So we take just now the 1.72 times 10 power 20, negative 20, and multiply. Okay, so when you press the calculator, remember you put the bracket. Okay, then the final answer 1.584 times 10 power, 548 times 10 power negative 3. If you just write 1.55 is okay. Okay, so this one is the final answer. Okay, depend the question. If the question set like this, more easier you don't need to count the mass defect. Okay, after 3 example, now we're going to see the nuclear power station. Okay, nuclear power station is one of the power station to produce energy from the nuclear process. So this one nuclear process must be the nuclear fission. Okay, nuclear fission, because this one not related by the sun, because you want to produce a nuclear fusion is hard a bit because you need to sunlight. Okay, and also the temperature must high. So from power station, Okay, we're using the process a nuclear fission. Listen careful, fission. That means the bigger size we go to split. Okay, we separate by 5 part. Okay, you can see the label 5 part. Okay, actually power station we separate by two-part process. Okay, first part you can see this one, the thick concrete wall. Okay, this one is a reactor. Okay, this one is a reactor. That means the nuclear reactor. You want to happen the nuclear fission must in this part. Okay, 4 and 5. 4 and 5, this one is another part. This one is called generator. That means later they can generate the electricity. Okay, so from here you can see the part first. We go to explain is a 1, 2, 3 first. Okay, part 1, part 2, and part 3. So the part 1 normally they will happen the nuclear fissions. Okay, nuclear fission will happen here. So when you do the nuclear fissions, they produce large amount of energy. So all the water, you see the water just pump in, is it? All the water will become hot. Okay, because they absorb the heat from the reactor. So now this all water, first one they want to cool down lah. So after that, all the water when they just go to the loop, they become hot. Okay, when the water just become hot, they heat up. When they just heat up, they produce the high pressure steam. Important, we need this one steam. Okay, this one steam you go through the steam flow. Okay, go through the tube, they join with the turbine. Okay, they join with the turbine. So this one turbine, because got high heat steam, and also this one steam is a high pressure. So they will help to rotate. Okay, to rotate the coil of the turbine. In the turbine, sure got the coil and also magnet. Then can generate the electricity. Remember your Fleming right hand? There's an electromagnetic inductions. They're using the turning relative motion between the magnet and also the coil. They produce the induced EMF. Remember? So that means the turbine, they're still using this one concept, electromagnetic induction. So from here, when the steam just pass through the turbine, they will turn. Okay, help to turn the turbine, turn the coin. Okay, after that, when they just turn the coin, that means they can generate. Okay, they go to generator, then they produce the electricity. Okay, now you can see the bottom part. They got condenser. Okay, condenser, what's the function? Okay, now the steam they go to turn the turbine, is it? Some of the steam after turn, they will condense. Okay, they sure will condenser. So the steam will go back to the liquid. When it just condense, they will drop. All the liquid will drop here. Okay, so the liquid will be cool down because this one steam is very high temperature. So you can see this one is a cooling water. The cooling water flow through the loop. Okay, this one water in the loop is a cool water. So when the water just condenser come down, they're still hot, is it? So this one cool water can make it cool down. So the water become cool down, they pump again go into the reactor. So the water go in reactor must be cool water because they want to absorb the heat. If you hot water, then how to absorb the heat? So normally it's a cool water. They want to cool down, okay, the reactor. But the reactor later that they will produce a high pressure steam. Okay, because they heat up already. Then after that, this process will be repeated. Okay, step 3, you go here, the steam, then go up to number 4. Number 4, when it just condense, the water go back, so the water will be repeated and round. They're just like the one of the cycle. Okay, so from here, I will using the word to explain part by part. Okay, let's see the nuclear reactor first. Okay, the first part, there's a nuclear fission. Nuclear fission will happen here of the uranium-235. Then the chain reaction also produced. Remember the chain reaction just now I told you? Nuclear fission repeated and repeated. Then called chain reaction. You just only nuclear fission, the energy is not enough. They must repeat it. So we call it as a chain reaction. They produce the heat energy. Okay, number 2, this part, the water is pumped. Okay, the water is pumped into the reactor core to absorb the heat energy that's produced by the nuclear fission. Okay, nuclear fission, they produce the large energy, then it will become hot. So that means the water pump, they must go in to cool down the reactor core. Then after that, number three is the water boiling. Okay, the water boiling by the heat because they produce large energy, is it? So the boiling of the water produce high pressure steam. This one is a high steam. So this one steam they will channel to the turbine. They put one the tube, then they join with the turbine. So this one is the first part for nuclear reactor. Okay, how to happen about the reactor first? Okay, after reactor until the turbine, then the next part should be the generator. Okay, let's see the generator. Before generator, we're going to see this one process first. How to run. Okay, you can see are they moving? You can see how they're moving. The water is flow in. Then this one, the reactor core. Okay, nuclear fission is happen here. Then the coolant water, they keep moving like this. Then this one is a steam. This one steam should be the high pressure steam. Then we go to the turbine. Okay. Okay, now this part is a generator part. Okay, generator part, let's see part 4. Turbine is rotated by the high pressure steam. Just now the high pressure steam, they will straightforward go to the excuse me. Okay, after that they turn and rotate the magnet or coil. Okay, either magnet, either coil, they go to rotate in the generator. So the steam will condense into water. Okay, some of the steam after the turning, okay, used to turn the magnet or you say the coil, then finally there will condenser again. The steam condenser back become the liquid. Okay, so from here, the last part, number 5, the electricity energy generator is sent to consume via a power supply transmission system. So electrical energy they produce, after they pass through to the power station, then the power station will send to the consumer. Okay, so this one is a process for the nuclear power station, how to functions. Okay, this one's one of the short, the moving of the process lah. We're going to see how to function. Okay, first step must be the nuclear reaction. Okay, after that they produce a heat. Okay, the steam. The steam will pass through to the turbine lah. They turn the turbine. After that, the turbine will generate the electricity. If cannot to change some of the steam, then will condenser go back. Okay, condenser go back, then you go to repeat again. So this one is a process, how the water is flowing. Okay, how the water can produce a high pressure heat. Okay, the steam, then after that they go to turn the turbine. Okay, then we go to the next part, chain reactions. Okay, just now I said repeated to do the nuclear fission, there's a chain reactions. Okay, now they explain for you. If one of these neutron, okay, remember the fission is a neutron go to bombarded the uranium, is it? So they bombarded another uranium. So that means nuclear fission, they produce how many neutrons? We got 3 neutrons, don't forget. So if this one 3 neutron, they continue, continue to bombard the unstable nucleus, you think what happened? Okay, the energy will be repeated and repeated to produce. Okay, so from here, they say another, another uranium, they go to hit, then the nucleus, then more fission will occur. So releasing more of the neutron. So a chain reaction is produced. So from here, you must remember one process is fission, neutron bombarded uranium. Okay, after that, they split, is it? Then they produce how many neutron? 3. Then these 3 neutron, they will continue to find the uranium, or you say the unstable nucleus. They go to bombard it again. So that means the process will be continue, is it or not? When they just continue, they also produce a neutron. Then this one neutron will continue to do the nuclear fissions. Finally, the whole process, we call it as a chain reaction. Okay, for this one, chain reaction should very, very large amount of energy will produce. Okay, so from here, as a uranium atom, they continue to spread. So the significant amount of the energy is released. One part release one energy. Now you got so many neutrons. That means you got so many energy that we produce together. So from here, the heat release is harnessed and also used to generate electrical energy. A controlled chain reaction, that means just like the power station, if we can control the nuclear power station, we can using this all energy. If you cannot control, okay, cannot control the nuclear fission, the chain reaction, what happened? Okay, the energy too large, more already over and over, so it will produce the nuclear bomb. Okay, they produce about the nuclear bomb. Okay, so this one we see the diagram for chain reaction. So you can see this one is a process chain reaction. The first part only fission. Then the 3 neutron, they continue to find the uranium. So that means they will repeat it and repeat it. So many energy they will produce for these situations. Okay, so the energy they produce used for where? Used for the power stations. Okay, now we're going to see control of the rate, because too much energy we need to control, is it? If not, they're used for the nuclear bomb. So we want to using for nuclear power station, so we need to control. So now they ask, just tell you how to control and also what's the safety we need to use for the nuclear reaction. Okay, first one, let's see the control part. How we go to control? Okay, control rod. You can see the black color, the one stay, one. That one is a we call a control rod. Okay, control rod normally made by the boron, or you say cadmium. Okay, 2 things can be used to make the control rod. What's the function for control rod? Control rod is reaction rate by absorbing the excess neutron. So that means the neutron too much already, they go to absorb. Okay, when they just absorb the neutron, that means the process can be reduced. Agree? Okay, because they need the neutron, neutron need to bombard it. If you just absorb the neutron, that means the neutron not enough, so the whole process can be slowed down. Okay, number 2 is a moderator. Moderator is a gray color, this part. Moderator is slow down the fast moving neutron. Okay, neutrons still come out, but they make the neutron slow down. Okay, slow down. Okay, release that nuclear fission can occur. So that means they slow down the neutron. So this one can make the whole process slow down. Okay, neutrons still come out, but they go make it, the process becomes slow down. Just now the control rod is totally go to absorb the neutron. Okay, they absorb the neutron. That means the rate for nuclear fission can be stopped. Okay, can be stopped because you absorb already. But the moderate just slow down. The process still going on, but they slow down the process. So they make from the material such as a graphite, or you say water. Okay, graphite. Okay, this one is a moderator. There's a graphite. Okay, now we're going to see the safety. What's the safety we need to do? First one, they got concrete wall. Okay, the wall must be a concrete wall. First one, the reason must be prevent the radiation from leakage, okay, to the surrounding. Okay, another one should be the water as a cooling agent. Okay, we're using the water as a cooling agent. The first one, we can explain water sure be easy to get it lah. Number 2, the low cost. Okay, number 3, you must say absorb heat energy from the chain reaction to generate the steam. Okay, because water is a high specific heat capacity that can store much of the energy, that can control the reactor temperature. Okay, so this one is a what safety we do it. And also the last part, you can see this one should be the uranium rod lah. We must have the uranium. Then after that, nuclear fission can be happen. Okay, so this one is a some example how we go to control. Okay, after that we got safety. Okay, so I finished about the 6.2. Now is the time for calculations. So you give me some time. Here got a little bit question. I think 3 or 4 lah. Okay, so you also need to prepare your calculation again. Okay, start. Question number 1. Okay, in a nuclear reaction, two deuterium, when you see deuterium, sure is a smaller one. Okay, they are fused to form one of the helium isotope. So this one should be the smaller become bigger. So let's see the equation. Okay, two deuterium, after that to form the helium and also the neutron. Okay, this one is an info for the mass in AMU. Okay, the question. Name the type of the nuclear reaction above. This one is what nuclear reactions? Okay, anybody can answer me? This one is what nuclear reactions? Okay, nuclear reaction, we just got two only, ma. Is it? Okay, so from here, you can see there's a smaller become bigger. So this one is what nuclear reaction? You can type here. Okay, type in the chat box. Okay, just a simple question. Okay, anybody? Nuclear reactions. This one is what nuclear reactions. Okay, yeah, thank you. Okay, nuclear fusion. Yeah, correct. Okay, so this one is a nuclear fusions because we find it there's a smaller, is it? Okay, nuclear fusions. Second question. Okay, you need to determine the mass defect in kilogram after these reactions. Okay, so that means you need to find the mass defect lah. So what you need to do, you find AMU first, then you convert become kilograms. Okay, AMU first, then you convert become kilograms. Okay, take some time, huh? So the student, you need to do the calculations for AMU first. Okay, after that, you straightforward convert become kilograms. Okay, so the student, you need to take the calculator and do some calculations lah. Okay, don't press wrong. AMU, all the masses must get the full number. Don't cut it. Okay, mass defect. Okay, we see which ones the student can give me the answer for the mass defect in kilograms. Okay, you can straightforward convert to kilograms. Okay, we go to wait. I think this topic is quite easy lah, because they just two subtopic, then we can finish about the chapter 6. Okay, only about the formula is just one, there's a E equal MC squared. And the rest we don't have. Okay, anybody can respond? Finish calculate or not? Okay, be careful when you do the calculations. Okay, I think the number is more than the student when they just start. Take some time. Okay, we take some time for the student to answer it. Okay, we're still waiting. Still no answer. Go or not? Okay, if don't have, that means I need to show lo. Go or not? Okay, let's see the student got type or not. Okay, almost 1 hour already, our lesson. Okay, you get ready. 6.64. Okay, we go to check. Okay, we'll check first. Okay, we get the AMU first. 4 times 10 power negative 3. Okay, then I convert become kilograms. Okay, remember gram must be full, don't cut. Okay, 6.64 times 10 power of negative 30. Okay, correct? Mailing correct, huh? Then we go through to the C. Question C. Okay, question C, I copied just now the answer, the mass defect. They ask you calculate the energy release. So energy release, we must using this formula lah, is it? Okay, now your turn. You straightforward take the mass defect, go to multiply the speed. Okay, remember the speed of the light, 3 times 10 power of 8. Okay, 3 times 10 power of 8 is the speed of the light in the vacuum. So remember, go to square. Okay, we're going to check the answer from the student. Okay. So I think there's no problem for yours to do the calculation, almost the same like just now the example question. Okay. So this one is an exercise that means you can download from the description there. I already put the link. Okay, this one is the sum of the question from there. Okay, anybody can respond? E equal mc square. Okay, remember square. Okay, we get it. 5.976. Okay, we take the mass defect, you go to multiply the speed of the light. Okay, 5.976 times 10 power negative 13 joule. Okay, so this one is a simple question. That means you follow the step, actually you can apply it. Okay, now we're going to see the second question. Okay, in the nuclear reactor, the nuclear reaction occurs shown by the equation below. Okay, you can see this one sure is a nuclear. Do you know what reaction? Later you need to answer. Okay, bigger size, spread smaller. So the first question, okay, see the info first. This one is the info. The first question they ask you, what is the nuclear reaction above? So this one nuclear reaction we call what name? Okay, we wait the student to answer. I think they also no problem for yours lah. This one just only the simple question. What's a nuclear reaction? Okay, you must know the nuclear reaction before you must go through the equation. They show you the equation that we understood already. Okay, so from here, anybody? Okay, this one reaction, we call it as a nuclear. Okay, fissions. Okay, we get the answer already. Nuclear fissions. Okay. Then we complete. Okay, then the second one. The second one, sure, they want to find the mass defect. Okay, mass defect. Okay, Sikajin correct, nuclear fissions. So from here, mass defect, I just show how to do the calculations. So you go to check lah. So from here, I just find it. The mass defect, I need to convert become AMU first. So I go to show. Okay, this one more step a bit. Because N plus U, you need to take the neutron plus the uranium. Then you need to minus the SB. Okay, SB plus the NB. Okay, don't forget here got 4 neutron. You need to multiply 4. Okay, then after that I go to minus, I get 0.19 AMU. Yes, AMU. So from here I need to convert become kilograms. So I just multiply, then I get it 3.154 times 10 power of negative 28 kilograms. Okay, so this one we call it as a mass defect. From where? From the nuclear fission. Nuclear fission got more number, you need to minus. Okay, so after that the C, sure they want to find about the nuclear energy. So we just apply. Okay, one more thing to tell you. You can see this word MeV. That means they don't want joule. They want the unit is a MeV, the mega. Okay, mega electron. So from here you see, Okay, they got one of the info here. Okay, nuclear energy can be expressed in the unit mega electron volt. Okay, we're not only using the joule, they can convert become mega electron volt. Now you can see this one info. 1 mega electron volt, they equal to the 1.6 times 10 power negative 13 joule. So that means later you find the answer in joule, you convert become mega electron volt. So from here, I take out just now the mass defect. Okay, I go to find the energy first. Okay, E equal mc square, I go to multiply. So I get the answer is 2.8386 times 10 power of negative 11 joule. Okay, but this one not the answer because I want the unit is mega electron volt. So what I need to do, I need to divide. Okay, I need to divide. So I take just now the energy over 1 mega electron volt. Okay, I over. So finally, I can get my answer in mega electron volt. That is 177.4125. Okay, mega electron volt. Okay, so this one is a one extra work you need to do. If they want to calculate the nuclear energy in mega electron volt, so you need to convert. Okay, from the joule you go to convert, then you need to divide by 1.6 times power negative 13 joule. Okay, so this one is an extra one of the step you need to do for this question. Okay, so from here we need to go to the next part. That's a number 3. Okay, number 3. Okay, the nucleus of the thorium-228 experience an alpha decay. That means they come out the alpha. So from here you can see the equation. Okay, they just produce the alpha. So this one just a normal radiation decay. So from here, the first one, they want to calculate the nuclear energy released in the joule. Okay, nuclear energy is straightforward. So that means you need to find the mass defect. After that, find the energy. Okay, so from here, they give you the info. Okay, TH 228.0287. After that, Ra 224.0202. Then the last one should be the helium. Okay, now the student, you need to find out what is the mass defect. Okay, I want the answer from you. Give me the mass defect. Okay, mass defect, you can straightforward give me kilograms. Okay, you give me the kilogram first. Then later we go to convert, become energy. Okay, so this one is your turn to do it. Okay, your turn to do it, to press your calculator to get the mass defect. Okay, for the alpha decay. Alpha decay is more simple a bit lah. Okay, we just got 3 things. You take the TH, you go to minus the Ra, minus the helium. Then you get AMU. Then you convert AMU to kilograms. Okay. Okay, we already over 08 minutes already, yeah? So give me some time, around the 15 I can finish. If you answer me fast lah. If you answer me fast, that means we can finish around 11:50. Okay, I think some of the exercise already shared there. You can see already, is it? There's a one of the Google Classroom. They got one of the exercise essay. Okay, there's an essay, so you need to do as a PBD marks 4 point. This one is a 6.2. Okay, another one should be the Google form. Already generate the Google form. That means you need to go to key in. Okay, for the 5 question for today attendance. Later I'll give you the code. Okay, anybody can answer me for this question? Okay, answer me first. Don't straightforward go to do the Google form. Okay, answer this one first in kilogram first. Okay, anybody? Answer in Google, answer the mass defect. Then we convert, become the energy. Okay, Sikajin can answer or not? Zixuan? Yiru, faster, go to answer this question first. Okay, answer the mass first, then we go through to the energy. Okay, Mailing, give me a ready. Okay, yeah. Okay, we go to check. Okay, yeah. There's a 9 point. Oh, yeah. In AMU, I go to convert to kilogram first. Okay, 9.78902 times 10 power negative 30 kilograms. Okay, and the last part, we go to convert, become energy. Okay, we go to energy. So we straightforward multiply 3 times 10 power of 8. Then remember square. Okay, yeah, Iru, give me the final answer 8.810118. Okay, we go to check. Wait, okay, here. So the answer E equal mc square. Okay, we go to multiply. Remember, go to square. Final answer 8 point. Where is that? 8.8101. 118. Okay, so this one is the final answer. 10 power negative 13 joule. Okay, I think this one should be the last one. Okay, what you need to do today is you need to complete the formative practice 6.2 from your textbook. Okay, so Google Classroom today we got one of the exercise only. There's an essay question as a PPT. Okay, another one should be your Google form. Okay, Google form for today attendance. Okay, today code. Okay, help me to type. Today the code. The code is a hashtag. Hashtag energy. Energy is a capital letter. ENERGY. After that, you put underscore 2021. Okay? Hashtag first. Hashtag, then energy capital letter, underscore 2021. Okay? Anybody here can help to type. Okay, we can show about hashtag first. Okay, you put hashtag, then after that you put energy capital letter. ENERGY. Okay, then you put underscore. Okay, then the number should be 2021. Okay, so this one is a today, the code. Okay, yeah, thank you, Iru. Okay, so today code, don't copy paste, you need to type by yourself. Okay, hashtag energy capital letter underscore 2021. No spacing, no spacing. Okay, do it after finish, you go to enter, no spacing. Okay, so our lesson just until here. So that means the chapter 6 we already finished. So when the school just open for next week, I will go through to the chapter 4. We still not yet finished. Okay, to the chapter 4 first. Okay, we got 4.3. There's a transformer. Okay, so our lesson just until this part. Okay, please do your PPD as a scholar. They must have the score. So you need to turn in. After finish, remember turn in. You didn't turn in, I don't know you got do or never do. Okay, thank you everyone. Okay, thank you Yiru, thank you Jessica Ho, Ling Han, and also Khatija, Mei Ling. Okay, and after that we got who? We got Zixuan, we got Dendrich. Okay, bye everyone. Just enjoy your 2 days for the holidays. Then Monday we start school again. Okay, bye. Everyone, bye.